I'm on whatever page this is. There you go. Okay, yesterday we started the study of differential equations. And differential equations are just equations that involve derivatives. That's it. That's the big picture. Application problems all over the place. Any field of study you're going to go into, medicine, engineering, mathematics, science, even business, involves differential equations. The manager at McDonald's may or may not know about differential equations, but even if that's your aspirational goal, I want you to be like the manager at McDonald's that understands differential equations. It could be a she. Okay. In the world of differential equations, there are what we call simple ones. Simple, not to be confused with easy. A simple differential equation looks like dy dx equals x squared plus 6. This is my derivative, and I'm going to solve this problem. How am I going to solve this problem?
The antiderivative.
You're going to find an antiderivative. You're going to say y is the antiderivative of x squared plus 6, and everybody knows that this is 1/3 x cubed plus 6x plus c. These are the simple ones. Not easy. They're simple because you just integrate or just find the antiderivative. Now, sometimes you get an initial condition. If you have an initial condition, you don't stop here. This is what we call a general solution. If you have an initial condition, you can plug in the initial condition and you get to a particular solution. And that's where we were yesterday. And I think for the most part, we're okay?
Yeah.
Most part? Mm-hmm. There are some application problems. There's going to be like word problems. There's going to be some reading that we do. Today I'm going to introduce you to something called a separable, S-E-P-A-R-A-B-L-E, differential equation. We're going to spend the next 3 days looking at separable differential equations. What makes a differential equation separable is that you're going to be able to write it as like a function of x times dx is equal to some other function of y times dy. You'll notice this side over here, all x's. This side over here, all y's. It's a function of x, everything's in terms of x times dx. A function of y, everything's in terms of y times dy. Simple is what we did yesterday. Separable is where we're going to spend the next 3 days. Everybody okay? Okay. Now, regardless of the type that you're looking for, what we're looking in the solution has to satisfy these criteria. It's going to have to be a function. It's going to have to be continuous. You guys remember continuous, no holes, no jumps, no breaks, no vertical asymptotes. And you're going to have to indicate the domain. Meaning, what are the x values, what are the inputs that you can use in your solution? But a solution has to be a function, it has to be continuous, and we're going to indicate the domain. This is where we are. Okay. I'm not going to ask if anybody has any questions yet. I don't think we're ready for any questions yet. But I want to introduce you to your very first ever separable differential equation. I can tell you right now, for those of you that are good with integration, you're going to be just fine. This is going to go really well, but the problems are long, and you're going to get a lot of practice. I have faith. All right, so here's what the problem's going to look like. Solve the differential equation y times dy dx plus 1 over x cubed equals 0, subject to the initial condition y of 1 equals -3. If the solution involves a domain restriction, be sure to indicate the proper domain for your solution. Okay, first order of business, is this a differential equation problem? I need to be convinced, but how do you know it's a differential equation?
Solve the differential equation.
Sylvia, what does it say?
Solve the differential.
Good reading. It says solve the differential equation, therefore it's a differential equation. But why is it really a differential equation? Karina, why is this really a differential equation?
Well, it seems to be a separable differential equation because it has the f and the derivatives and the y's too.
We're going to come back to that. I'm not ready yet to declare that this is separable. My question though is, why is this a differential equation? What do you see? I mean for this to be an easy question, and I think I'm not pitching it well. Daisy?
You have the dy dx.
You've got the dy dx, right? The dy dx means derivative. And oh my gosh, it's in an equation. So this is a differential equation. Sometimes your differential equations involve the first derivative, sometimes it involves the second derivative. Now I want to actually look at this one. Y times dy dx plus 1 over x cubed is equal to 0. Yesterday, back in the shallow end of the swimming pool, we were looking at differential equations and they all had the same form. Kevin, you okay?
Yes.
They all said dy dx equals blah. Or d squared y dx squared equals blah. They all said the derivative equals stuff. Okay?
Mm-hmm.
So now you might try and say, oh, okay, well let's get that there. What's the algebra that we can do to get dy dx all by itself?
Divide by y.
You could divide by y. I'd probably do something else first.
Oh,
Minus
subtract the 1 over x.
Maybe subtract the 1 over x cubed to the other side. Yeah, I like that. And then
divide.
divide by y. If you divide by y, you're going to get negative 1 over x cubed divided by y. But to divide by y means multiply by the reciprocal. What you get is negative 1 over x cubed times 1 over y. Just want to pause for a second there. I want to let you take it in for a moment here. I want you to have a little freak out for a moment here. There's something a little scary happening in this differential equation. You've got multiplication happening. Okay, apparently Julius is afraid of multiplication. There's more than that though. Henry, what else is the problem?
You got x and y on the same side.
You've got x's and y's mixed in on the exact same side. In the world of simple ones, that did not happen yesterday. We always had derivative in terms of x. Now you've got derivative in terms of x's and y's. And so this is where I'm going to try this technique called separation of variables. We're going to say separation of variables, maybe. Because we're going to realize that this doesn't always work. So separation of variables, the technique is you get all the x's on one side, including the dx, all the y's on the other, including the dy. I just need algebra, clever algebra. Anybody get some clever algebra? All the x's and dx on one side, all the y's and dy on the other. Jackie, what do you see?
Multiply dx on both sides.
Multiply dx on both sides. My first question for everybody, is that legal?
Mm-hmm.
Right, I care about legal. So dy is negative 1 over x cubed times 1 over y dx. Legal, is it better? Maybe, right? I got a dy over here, I got a dx over here. But this side's starting to get a little scary for me. Because now I've got x's and y's in the dx. If this is truly separable, you can get all the x's on one side with the dx, all the y's on one side with the dy. I need more legal algebra. Andy, you get some thoughts there? No? Okay, fair enough. Legal algebra. Jeanette?
Divide by 1 over y.
Divide by 1 over y. Would that be legal to do?
Yeah.
Yes.
Okay. Now, I heard you say divide by 1 over y. Others might be like, no, just multiply by y. Sames. dy divided by 1 over y is y times dy equals negative 1 over x cubed dx. Have we separated the variables? Function of y with the dy on one side, function of x and the dx on the other side. Congratulations, you've earned the first point. The variables have been separated.
You have to do all of that.
Dude, we haven't even started. We've just done some algebra to say this is a separable differential equation. Now what we're going to do next is we're going to integrate both sides. We're going to integrate both sides. And in the world of calculus, this is legal as long as you do it to both sides. Right? Just like we can add things to both sides and we can multiply both sides, we can integrate both sides. And I bet one of these sides is easier to integrate than the other. Take a minute, what's the integral of y dy? What's that antiderivative? Okay, if you know what that is, go for the right-hand side. What's the antiderivative of negative 1 over x cubed? The integral of y dy is 1/2 y squared. The integral on the right, though, negative 1 over x cubed. How am I going to integrate negative 1 over x cubed? I was hoping for more folks on this one. Negative 1 over x cubed. What do you see, Henry?
X to the negative third.
Okay,
I mean negative third.
negative x to the negative third, and now that's going to be helpful because we get the power rule. And the power rule says add 1 to that power, and then divide by that power, and don't forget about the negative that's already there. And that's what's going to make it positive, but I don't want to jump straight to the positive. Now we get a little bit of a problem here.
Isn't it plus Charlie and then plus beta? Or are they both plus Charlie?
It should be plus Charlie, right? When we find the antiderivative, there's that constant of integration. The integral of negative x to the negative third is the negative 1/2 x to the negative 2. Now, some people are going to be tempted to say plus Charlie, and here's a concern. When you find the antiderivative, there is a constant of integration, but it could be any constant. This guy over here could be any constant. There's nothing that says they have to be the same,
So we change it?
so I'm going to change it. I'm going to call it like c sub 1 and c sub 2, just to indicate these are different constants of integration. Is everyone kind of okay?
Yeah.
All right. In terms of how I'm going to score this, if you integrate correctly on the left, 1 point. You integrate correctly on the right, 1 point. If you remember the constant of integration somewhere, another point. You're already up to 4. You're close to being done, but you're not done yet. You're not done yet because your solution has to be a function, meaning I want to see y equals. It has to be continuous, and you need to indicate the domain. To get it as a function, we're going to solve for y. The good news is we're done with the calculus. The bad news is we're done with the calculus. All I need is legal algebra to get to y. Minus what? Minus the c1. 1/2 y squared is equal to, that's a negative negative, so that's positive x to the negative 2 plus c2 minus c1. All I did is subtracted c1 from both sides. And I want to introduce you to my new friend. My new friend is called Super Charlie. Super Charlie gets an upgrade in his skills. This is my friend Super Charlie. I would love to wear it on my chest. What do we know about C2? All we know is it's a constant, right? What do we know about C1? It's a constant. You ever take a constant and subtract a constant from it? What do you get? A constant. We're going to call it Super Charlie. Here, you get to possess Super Charlie for a little bit. You don't have to do this. I am well trained in the Jedi arts, but I like to just call that Super Charlie. 1/2 y squared equals 1/2 x to the negative 2 plus Super Charlie. You're still trying to solve this for y, and you're not done yet. More algebra. What are we going to do? Any more algebra? Everything gets multiplied by 2. 2 times 1/2 y squared is y squared. 2 times 1/2 x to the negative 2 is x to the negative 2. You know what 2 times Charlie is? 2 times Charlie. And it's Super Charlie. And Val, why is this Super Charlie? You're right. What do we know about C?
It's already super Charlie.
What do we know about C? It's a constant.
2 minus
What happens if you multiply a constant by 2? It's still a constant, Super Charlie, yet again.
Wait, what?
Super Charlie's got some mad skills.
Wait, so you like, so you just like disappears?
It's not that it disappears, we're replacing this with a different constant. We're still gonna call it Charlie though, and it's totally legit. You're still not done because you are trying to solve this differential equation to get a function that is continuous, and we look at domain. Guess something.
Isn't it negative x to the negative 2?
Isn't it negative x to the negative 2? We had negative x to the negative 3. Add 1 to the power, we get x to the negative 2. Divided by that new power. And there was already this negative from before, so I'm pretty sure it's positive. Okay, everybody still okay? We have to solve for y. So we're going to take a square root. And here's where we've got to be careful. When you take the square root, you've got to consider both the positive and the negative versions of the square root, because both could work. Both could work. Jackie?
Can you just start plugging in the 1 and the 3
Okay, where's the 1 and the 3?
in the problem? Like, why go through all the problem with square rooting it?
Okay, that's a good question. So this y, I think what Jackie, what you're bringing our attention to is our initial condition. The initial condition says that y1 is equal to negative 3. Well, if y1 is negative 3, that means if x is equal to 1, then the y value is equal to negative 3. You need to build this function in such a way that it satisfies this initial condition. So how about plug in the stuff in? Negative 3 is plus or minus the square root of 1 to the negative 2 plus c. Well, let's see. What is 1 to the negative 2 power? That means 1 over 1 squared, which is 1. Some of you might be able to just look at this and you know what c is. Negative 3 is plus or minus the square root of 1 plus c.
8?
C should be 8, right? You could square both sides if you want to, and you're going to get that 9 is equal to 1 plus c, so c is equal to 8. So you've got y is equal to plus or minus the square root of x to the negative 2 power plus 8. Destiny?
What happened to the 2 when you was in the simplified?
The 2, so because Charlie is a constant, it could be any constant, and we don't even know what it is yet, and we don't care about it. When you multiply a constant by 2, you still get a constant. So I'm just going to call it Super Charlie. Paul? Okay. We're all good? Ish? All right, so here's the thing. Before you're like, oh, I'm done, here's my answer. Y equals plus or minus the square root of 1 over x squared plus 8. We've got two things that we need to have a conversation about. Number one, is this a function? If you were to graph this on your calculator, would it pass the vertical line test? And if you're not sure, feel free to take out your calculator and graph this on your calculator. Yeah.
So right there you had a square root of 1 plus c.
Yep.
You just square root of both sides, right?
We squared both sides. To get rid of, right? So we squared this side and squared that side, and that's where we get 9 equals 1 plus c. For those of you that are graphing this on your calculator, this isn't going to be a function. You're going to have like a part of the graph above the x-axis. You're going to have a part of the graph below the x-axis. That's going to be a problem. It's not a function. We have to make a decision. Do you want the positive version or do you want the negative version? Do we want the positive version or the negative version? And how you decide, you've got to look at the initial condition. You're looking at a differential equation, and you've got an initial condition, meaning like the curve has to pass through this point. The curve has to pass through 1 comma negative 3. So do I want the positive version or do I want the negative version?
Positive.
Uh-oh.
Find it out.
Which one?
Positive.
According to the initial condition, y1 is equal to negative 3. If I plug in 1 for x, I get negative 3 out for the y. So So do we want the positive version of the square root or the negative version of the square root?
Oh, negative.
It has to be the negative? Okay, good. Almost perfect. I know this is a long problem. And I'm watching my Super Charlie here because I think Evel's going to try to steal it. What are we looking for in a perfect solution? It's over there. What do we need?
Function.
A function. We got a function.
Continuous.
Continuous. No holes, no jumps, no breaks, no problems.
Indicated domain.
And we have to indicate the domain. Does this graph, look at this with your pre-calculus eyes, have any problems?
Yes.
Any problem areas? Any places where the graph won't exist? Paul sees it. Jackie sees it. Look at that function. Are there any places, any values you can't plug in here? Karina, what can't you use?
Well, based on like the equation,
Yep.
shouldn't it be like number 8? I mean like it's
Rubio, help me out here.
0.
What about 0?
You won't be able to use 0 because
You don't be able to use 0 is what I just heard. Why?
Because you get 1 over 0.
You get 1 over 0 and you don't ever want to be dividing by 0. Now here's the problem. This is the last part of the conversation and then we're done. Is everybody okay that x can't be equal to 0? We don't divide by 0 ever. What that means is you need to consider your number line. My number line goes from negative infinity to infinity. X equals 0 is a problem area. If your function is continuous, that means I can only use numbers to the left of 0, or I can only use numbers to the right of 0. Which side? Go back to the initial condition. Your solution has to pass through the point 1 comma negative 3. So do we want to be on the left of 0 or the right of 0?
On the right.
You have to be on the right because of the initial condition. So your final answer is x's are greater than 0. Everything comes down to that initial condition. Everything comes back to that. Okay, I know that problem was long. I'm going to leave it up here. I'm going to take some questions, but I want to give you guys some practice time so you can develop the skill. The practice problems. There's some practice problems starting on the bottom of page 10. The practice problems are going to be much easier, much kinder than this one that we just went through. I wanted to push. I think I did. And I think we're okay for the most part. And I'll come around and answer questions.
So you said here, like, we might not be able to separate the variables, so if we're not able to use something.
Right, if you are not able to separate the variables, you would need a different technique, which we don't know yet. Because right now, we have only these two. You get the simple, just integrate, and then you get separable. And this is just still the baby and I know. It's still not time to cry. Okay, because our solution to a differential equation has to be a function, it has to be continuous, and we want to indicate the domain. Back over here, Karina, when we realize that the x value can't be 0, cannot be 0, that means we're dividing up our x options. I can't use 0. My function has to be continuous, so I can either use all the numbers greater than 0 or all the x values less than 0. And the way that you choose, you go back to the initial condition. You got to go back to the initial condition. And because I need to be able to plug in 1, that means stay to the right. All right, I'm going to keep walking around. Stay with me.
Yes. So we learned the simple version already? Like
Simple day was yesterday.
Yeah, so this is like the new one?
This is the next technique. But you don't know, here's the thing, Henry. You don't know in the beginning if it's a separable differential equation until you do the algebra and you get x's and dx on one side, y's and dy's on the other.
So like, are you trying to get the x's on one side and y on the other side? Or that's
Yes, because this is when now I can say, oh, this is a separable differential equation because I could separate the variables.
I thought I have it by accident, and then you find out.
There aren't many accidents in this class. Careful planning is what you're thinking.
Oh, okay.
Okay? But Henry, there are worlds of questions out there that are not separable. We're only looking at separable ones for the next couple of days. Monday we'll look at the non-separable. Can't wait, don't be absent Monday. If you just skip that AP Spanish benchmark.
Oh, yes,
No.
Okay, it's already
Just
said.
commit to watching the video.
No, it's already said. Yeah. Skip it. Just bring him into the road.
Oh, thank you, Dave.
Super Charlie.
Yeah, what's so hard about that?
I'll show up. Leave it. Ya terminé.
We have the speaking.
Then you have to stop.
Yeah.
Yeah, focus.
No quiero.
But do you think they're already on?
Okay, I'm seeing a lot of good progress first. You have to see, is it actually separable?
Oh, no. So yes, like that.
Okay, and most people successfully made it to y times dy equals x times dx.
Yeah.
Everything in terms of x on one side with the dx, everything in terms of y and the dy on another side. Congratulations, all the AP calculus teachers say award a point. Variables separated. Your next move? Integrate. 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 Integral of y dy.
1/2 y squared.
Weren't you supposed to put this?
Plus Charlie.
1/2 y squared plus Charlie. Integrate over here.
1/2.
1/2 x squared
Plus Charlie.
plus Charlie. Be careful. There's like C1 and C2. Okay, how many of you guys made it to this point? We're in a much kinder question than before. Okay, much kinder, I know. You integrated correctly, I'll give you a point. You remembered the constant of integration, I'm gonna give you a point. Now what are you gonna do? You're gonna go solve for y. And it's gonna be fast, fast, fast. Solve for y. What are we gonna do?
Multiply by 2.
Maybe you wanna multiply by 2. Maybe you wanna subtract C1. Now, here's the thing that's gonna blow your minds for some of you. That C1's always gonna cancel out, right? Always. So now you've got 1/2 of y squared equals 1/2 of x squared plus C2 minus C1. Super Charlie. I am telling you right now on video for all the calculus teachers in the world to hear it, if when you do the integration, you want to integrate both sides, but write Charlie on only one side, that's okay. Because think about what's going to happen. You're going to have something plus Charlie, something plus Charlie, and the first thing you're going to do, subtract C from both sides. So if you just want to say, oh, you know what, I'm not going to bother writing Charlie over here, that's okay. Okay, pick your next move. Multiply by 2. So y squared equals x squared plus 2 times c?
Yeah.
Just Charlie? To get to y, plus or minus the square root of x squared plus c. We're doing well. Jesus is excited. He's like, I'm going to take more days off. Y of 1 equals -3 means x equals 1. Y is equal to -3. Plug it in. -3 is plus or minus the square root of 1 squared plus c. We know what c is? Uh-oh, that was awkward.
No, I don't know who said that.
Yeah, that wasn't Destiny. Nope. We get 9 equals 1 plus c, so c is 8.
Yeah, that's what I
Okay, that's exactly what you said. So y is plus or minus the square root of x squared plus 8. And you're going to be tempted to stop. Think about what I'm looking for. I want a function that is continuous, and you gave me the domain. Do we have a function? Nope.
Not yet.
No.
Oh, you have to choose one.
Yeah,
You have to make a choice. This plus or minus is giving you two completely different functions. So do we choose the positive version, or do we choose the negative version?
Negative.
Okay, and that was pretty resounding negative. The way that you make the choice, look at the initial condition. I need the y values to be negative. That doesn't happen here.
That's greater than 0.
So I've got a function. Is it continuous?
No.
Yes.
Think about this for a second. What are you looking for?
Oh,
Differential.
it's not a -3.
Are there problem areas here?
Yes.
Are there things you can't do? We can't divide by 0. And another thing that you can't do in math class ever?
Square root of a negative number.
You don't ever want to take square root of a negative number. Right? You don't want x squared plus 8 to be negative. What do we know about x squared plus 8? X squared plus 8.
Okay.
Any number that you square
Yeah.
and you add 8, guess what?
It's positive.
Is always positive. X squared plus 8 is always positive. So what's your domain?
X greater than
Everything.
0.
Not x greater than 0.
From infinity.
All the numbers.
What numbers can you plug in here and be okay? All of them. The domain is all real numbers. You guys are off to a great start. Keep going. I'll just keep walking around. And
Oh, where do you put the 2
why didn't I put 2 superterm? Because when you distribute this 2 through, Daisy, the 2 gets multiplied through. C is a constant that you don't know. It could be any constant right now. So doubling a constant that you don't know, still a constant that you don't know. Okay, keep going.
Because you plug in 1, right?
Oh,
And you're
awkward.
it's positive.
You missed this one. He's actually working on a separable differential in the middle of his exam right now. We're looking for linear algebra that is going to separate those variables.
I thought
That's fine.
Where were my AP Spanish language folks again? Okay. Karina,
Yeah, I skipped it. Just give me a pass. I don't know.
Karina, Daisy, Michelle,
Gonzalo.
Gonzalo, Chris.
Gonzalo taking the AP test. The Spanish
The
benchmark.
benchmark is Monday.
The Spanish one. Supposedly yesterday.
Yeah.
I know, right?
Is Flora an AP Spanish language? No. Jeanette, are you wanting to take AP Spanish language?
No.
You can take my quiz.
And I'm Ryan until the 6th.
Okay. That's good to know. Okay, thank you. Keep going. If you're ready for a challenge, I'd go to number 3. Have faith in your sparticle particles.
They're broke.
No, they're not broken.
What? What's broken?
There are no broken sparticle particles. You're going to be just fine.
Well, there is.
Mine are burned.
Mr. Roger, you sell yours?
Can I sell my sparticle particles? No. You couldn't afford it. Keep working.
Yeah.
dy sub 1 equals x dx. Yeah, that's yeah.
And that's all I'm
Like the name. Oh.
That's why yung best
You know
oh my
what
god.
you do? I haven't been watching
Way that it was this.
That's what I did on the weekend. I'm almost done with it.
They are getting the same equations.
Yeah. Well, for this, from of course they're not gonna be like that.
You really think?
Not really.
I saw someone that was like 24 that girl on the name.
Yeah. They did take it up there.
So that's the green?
Oh, for real?
The first one we got like
Is it today?
greater than 0, so I guess it depends.
That's a y equals x plus
Okay, in about 1 more minute, everybody needs to go to number 3. It is, but in the beginning it didn't look like that. Right? It's through this like algebraic manipulation that you got to the same thing. Oh.
Oh, see,
All right, friends, we got 7 minutes. I need everybody on number 3. I have faith in the smarticle particles.
faith.
Faith.
He goes to church and prays.
I have faith for 58. That's the number of DeRosiers.
Yeah, I think he always prays for us in the church.
TA, are you okay with
Seeing some good moves. Oh, we got it. Except for me. 1 over y dx plus cosecant of x dy is equal to 0. I don't know about anybody else. I am not ready to say this is separable. You only know it's separable when you actually have legally separated all the x's and the dx and all the y's with the dy. So I've seen some good moves. What do we get to start? I'll take anything from anybody. What do you do? Okay, Julissa multiplied by y. Is that legal? Absolutely. Now if you do that, y times 1 over y dx is dx. Plus y cosecant of x dy is equal to 0. That's great. You got rid of the fraction. But you haven't separated the variables, and this is the problem. I need something else. I need more algebra at this stage. Who's got the more algebra? Oh, it's the same 4 or 5 people all the time. Need some algebra. Destiny, what you got?
dx.
Subtract the dx? Sure. So y times cosine of x dy is the negative of dx. That's absolutely okay, but you haven't separated things yet. Andy? Divide by cosecant, I completely agree. Now that's scary, I think, for a lot of us. Dividing by cosecant? What? But Andy, why did you decide to divide by cosecant? Because these guys over here are going to cancel out, and what you're left with is y times dy. Instead of negative dx over cosecant of x, I hope everybody's okay, I'm going to write negative 1 over cosecant of x. times dx. And my question, Axel, have we separated the variables? Absolutely. On the AP exam, we award you the first point.
Yeah.
And you know what to do next. Energize it? No.
Well, rewrite secant. I mean,
Integrate both sides. There is always going to be an easy side and there's always going to be a hard side. I think we all see the easy side. The y dy?
Yep.
Rebecca, what's the integral of y dy?
1/2 y.
1/2 y squared. Now, you have to write the plus c? You don't have to, as long as you write it over here. Good news, just picked up another point. Sad news, now you're left with integrating negative 1 over cosecant. And I don't know what that is.
Ignore it.
I don't know what that is.
Oh,
I don't know what that is.
yes we did.
If only there was something, if only there was something smart I could do. Cosecant is 1 over sine.
Oh, wow.
So what is this?
Sine.
Sine. If you're not sure what just happened, cosecant is 1 over sine. So negative 1 divided by 1 over sine?
I dropped my pencil.
Is negative sine of x dx. You get no point for that, but now everybody knows what this is. What has negative sine of x as its derivative? This is cosine of x. So 1/2 y squared equals cosine of x plus c. You integrated correctly. You got the constant of integration. What's left?
The y.
solve for y.
Solve for y. Oh my god, we're going to multiply by 2 again. Y squared is 2 times cosine of x, and I'm just going to write plus c. We get that super Charlie action happening. We're going to take a square root. Y equals plus or minus 2 cosine of x plus Charlie.
What happened to the
What happened to the what? The dx, remember the dx is there to say, hey, I'm the variable of integration. You found the antiderivative of negative sine of x, which is cosine. No more dx. Do we have an initial condition?
Yes,
Oh, thank God.
What is it?
So if x equals pi over 2, y is 4. We plug it in, 4 plus or minus square root 2 cosine pi over 2 plus Charlie. I'm still pushing the trig. I'm a pusher. That's what I do. Cosine of pi over 2 is 0. So 4 is plus or minus the square root of c.
16.
C is 16. You probably just picked up another point. Y is plus or minus the square root 2 cosine of x plus 16. Jeanette, what's up?
That would be a free response question, right?
Yep.
And how would you hide it, like, as multiple choice?
I would hide this from you.
Yeah.
Yeah. Okay, good question. Hold on though, because we're not done. We're not done. Oh, we're so not done. We've got to choose positive or negative version, and we have to have domain.
Positive.
Okay, Daisy, positive y.
Oh, because y is positive.
The y value is positive, so we have to go with the positive version. The domain, when is this going to be negative?
Never.
Cosine of x, the biggest it can be is positive 1. The smallest it can be is negative 1, right? You're always trapped in there.
Yep.
So what about 2 times that?
-2.
You go from -2 to +2. And then when you add 16, everything's positive. So your domain, all real numbers. Nice job, y'all. See you later. I know you want to stay forever, but you